Today's video I would like to introduce you a very nice problem of Vietnamese Mathematical Olympiad edition 1992, question number 5. Here is the following information. Find all x and y as a positive integers such that we have the following equation: x squared plus y squared minus 5 times is multiplied by x, y plus number 5 equals 0. Okay, in fact it's challenged problem, but we are going through all the details. So the hint that I'm trying to give to this problem, try to make the relationship between this variable y and x and consider all the cases as well as the symmetry, because it's clearly we have the symmetry here because x and y are written on the same form. We have x squared here, we have y squared here, so we have the product of x, y, so they are playing the same role in this case. So go ahead, pause this video if you would like to give that a try to this problem. When you come back to see the full solution. Okay, let's get into the solution now. So without loss of generality, so we have x, y is a solution, and we have y and x is a solution because of symmetry. Assume x is inferior or equal to y. Okay, by assumption I'm going through this one by considering x is inferior or equal to y all the way down. You can consider opposite of this one, y is inferior or equal to x, but you are going to stay on the same direction. Okay, so now this one will be broken into two cases. If x equals y, to see what's given us by replacing y with x into this equation, I will have x squared plus x squared minus 5x squared plus 5. So by calculating this one, 2x squared minus 5x squared is giving us minus 3 times x squared equals minus 5. Okay, so that's mean 3 is multiplied by x squared equals 5. Since x is a positive integer, this is impossible. Okay, so that's mean x is not equal to y. That's mean x is strictly inferior than y. So this one is telling us y equals x plus another integer plus a, for example, where is a is some natural numbers. We need to plug this fact into original equation to see what's given us. So I will have x squared plus y squared will be replaced with this one, which is x plus a quinary squared minus 5 is multiplied by x is multiplied by this one, x plus a plus number 5 equals 0. Now I'm going to distribute this one. I will have x squared plus x squared plus 2 times is multiplied by xa plus a squared minus 5 is multiplied by x squared minus 5xa plus number 5 equals 0. Okay, so x squared plus x squared is 2x squared minus 5x squared is giving us minus 3 times is multiplied by x squared. I will have 2xa minus 5xa, which is minus 3xa. Then I will have a squared plus number 5 equals 0. By multiplying both sides by minus sign, I will get 3x squared plus 3 times xa minus a squared minus 5 equals 0. This is form quadratic equation. I'm going to calculate discriminant of this one. Delta equals 9a squared minus 4 times is multiplied by 3 is multiplied by minus a squared minus 5. By simplifying this one is giving us 21 a squared plus 60. In order to have a solution for this equation as a positive number, this delta must be a perfect square. Okay, I'm going to put this one at the top and continue solving this equation. Indeed, our solution of this equation based on this expression. Okay, now we are going to have a lot of work on this one. Okay, in order to have the solution for this equation as a positive integers, this one must be a perfect square. Okay, So by doing some motivations, I'm going to divide this one into two major cases. Let's consider this equation has a solution. Let's suppose the equation has a solution for all a is strictly superior than 11. Okay, this one is telling us a equals 11 plus L. Okay, this one implies delta, which equals 21a squared plus 60 is a perfect square. Because if you have a solution for this one, that's mean this term delta is a perfect square. Okay, by the way of contradiction, I'm going to show this one is not a perfect square. Okay, by the way of contradiction, suppose delta is a perfect square. Delta, which equals 21, is multiplied by a square plus 60 equals m square. Okay, that's the definition of the perfect square. Okay, at the end of the proof we will find the contradiction. Okay, the first table I'm going to factor out this expression. So 21a squared plus 60, 21 is the same as 25a squared minus 4a squared. 60 is the same as 64 minus 4 equals m square. Okay, now I'm going to create a perfect square here. So this one is giving us 5a plus 8 quinary square. If I'm going to distribute this one is giving us this one 25a squared. The last term is giving us 64h squared. So the mirror one is giving us 2 is multiplied by 8 is multiplied by 5a is giving us 80a. But 80a we don't have it here. That's mean I'm going to subtract 80a minus 80a. Taking 4a squared and number 4 to the right hand side of this equation, I will get m squared plus 4a squared plus number 4. I'm also going to create another perfect square here, which is m plus 2a quinary square. If I'm going to factor out this one, it's giving me m square here, which is good, plus 4a square, which is here, plus 4am, which we don't have here. That's mean we are going to subtract that one, minus 4am, plus the original 4. I'm going to take this minus 80a to the right hand side of this equation. I will get here plus 80a. So I'm going to take this one off. Now it's clearly I will have 5a plus 8 quinary square equals to this term m plus 2a quinary square. And also I'm going to take number 4 as a common factor for these three terms. I will get number 4 here is multiplied by 20a minus am plus number 1. I'm going to reduce this one to mod 4 by using the congruence definition. If I'm going to put congruence definition, mod 4, this term it will be 0 because we have 4 here. That means 4 divided 4. This one is 0. That's mean this one is telling us 5a plus 8 quinary square congruent to this one m plus 2a quinary square mod 4. Now I'm going to replace a with its value. Okay, so one implies I'm going to replace 5a plus 8 by multiplying by 5 here. I will have 5a, which is 5l plus 55. I will have 5l plus 55 plus this 8 is giving us 63 plus 63 quinary square is a congruent to m plus, I will have the same thing here by multiplying both sides by 2 is giving us 2a, which is 2l plus 22 quinary square mod 4. Now I'm going to clean up this board and bring this one at the top and continue solving this problem. Now I'm going to do the change of variable by putting x equals 5L plus 63 and capital Y equals M plus 2L plus 22. Okay, so we'll have this one now. Now we will have the expression of x square is a congruent to y square mod 4. I'm going to do the chart when we have the perfect square, when we have x square and y square. So in general, if I have like n and n square, so whatever it is the same if I put x or n, whatever it is. So when we have, I'm going to reduce this one to mod 4 as a perfect square. So when we have n equal to 1, I will have n square is giving us 1. When we have 2, is giving us 4. 4 mod 4 is giving us 0. When we have n equal 3, that means 3 is giving us 9. 9 is the same as 1 mod 4 because we get number 1 over number 8. So let's check number 4. Number 4 square is giving us 16. 16 is the same as 0 mod 4. Okay, so let's check 5. 5 is 25. 25 is 1 more 24, which is 1, and so on and so forth. This one is keep going like this. So the perfect square here is occurred. So the only perfect square for n is just 0 and 1 mod 4. Okay, so now I will have the same. This one is telling us x and y is a congruent to 0 mod 4. So number 1 it will work too because we have 0 and 1 are perfect square. So this one is telling us x square is a congruent to 0 mod 16 because I'm raising this number 2 as a power on both sides. So that means is okay if I put the x square and 16 here. Okay, this is very important. So I'm going to replace this one with its value. X square equals 5L plus 63 quinary square mod 16. Okay, I'm going to keep this one for a moment. Now I'm going to go back to the original equation, this one. Okay, so we have this delta equals 21 is multiplied by a square plus 60. I'm going to replace a with its value. We'll have 21 is multiplied by 11 plus L quinary square plus 60 equals m square. Because by assumption I put this one as a perfect square equals to m square as I have before. Okay, if you take a look carefully at this term, we have 11 plus L. So I'm going to use a trick in order to get to this expression similarly. Okay, in order to do that, I'm going to multiply both sides by 25. Okay, so we'll have 21 which is this one is multiplied by 25 is multiplied by 11 plus L quinary square plus 60 is multiplied by 25 equals 25 is multiplied by m square. I'm going to put 25 as 5 square, so that means 5m quinary square. I can put it as p square. Okay, as we know, this term p square is the same as x square is the same as n square, is all congruent to 0 mod 16. Okay, based on the previous proof. Okay, so this one is a congruent to 0 mod 16. Now I'm going to put this 25 inside of this one. It becomes 21 is multiplied by 5L. When you take this 25 becomes 5 is multiplied by L plus 55 quinary square plus this term 60 is multiplied by 25 equals is a congruent to this one to 0 mod 16. This term is similarly looks like this one. So the only difference, we have 63 here, we have 55. So in order to get from here to here, I'm going to put the same term as is it. I'm going to subtract -8. I'm going to put 21 factor 5L plus 63 as I have here minus number 8 quaternary square plus 60 is multiplied by 25 is a congruent to 0 mod 16. Okay, I'm going to distribute this one. I will have 25, I will have 21 is multiplied. I'm going to, this one is giving us, I will have 5L plus 63 quaternary square minus 2 times 8 is multiplied by this one, which is minus 16 is multiplied by 5L plus 63 plus the last term, which is minus 8 quaternary square, which is 64. Okay, plus this term 65 is a congruent to 0 mod 16. I will have a lot of cancellation here. This term is 0 mod, I'm going to read this one. This one is 0 because we have it here. This one is a congruent to 0 mod. I forgot to put here. So when we have replaced this one with this one, I forgot to put 0 mod 16. Okay, so this one is 0, and also this one is 0 because we have 16 here. This one 64 is 0 because 16 divides 64. I will be left only with this term. Okay, I have 60 is multiplied by 25 is given as 1500 is a congruent to 0 mod 16. Okay, as we know 1500 is a congruent to 0 mod 16. 1500 is the same as 16 is multiplied by 93 plus number 12 is a congruent to 0 mod 16. Okay, this one will be 0 because we have 16 here mod 0 mod 16. So we'll be left with this one. 12 is a congruent to 0 mod 16. I have ended with this one. 12 is congruent to 0 mod 16. That means 16 divide 12, which is impossible. This is contradiction. What does mean contradiction? That's mean this term will have what we have shown is not a perfect square for all a is strictly superior than 11. Okay, that's mean the solution of this equation is on the interval when we have a is inferior or equal to 11. Now I'm going to clean up this board and move on to the solutions for this equation. The solutions of this equation is when we have a is inferior or equal to 11. Okay, to check all the cases, 1 from 1 2 3 4 5 6 7 8 9 10 11. Okay, as a positive integer. So I'm going to check when we have a equal to 1, if a equals 1. Okay, then this term become 21 plus 60, which is 81. Okay, so I will have delta equals 81. I will have delta equals 21 is multiplied by 1 quaternary square plus 60 is given as 81 is the same as 9, is the same as 9 square. Okay, now the solution for this equation, I will have x equals minus b, which is minus 3x, minus b, which is minus 3a, which is minus 3, plus square root of delta, which is plus 9, is divided by 6, is divided by 2a, which is 6. Then the second solution, I will have minus 3 minus 9 is divided by 6. This solution will be eliminated because we are working on the positive integers. So we'll have only this one. So we'll have x. 9 minus 3 is 6. 6 is divided by 6 is given as 1. Now I'm going to look for y by replacing x into the original equation. I will have 1 plus y squared minus 5y plus number 5 equals 0. I will have y squared minus 5y plus 6 equals 0. I'm going to do the same thing. I'm going to calculate the discriminant of this one. 5 squared given us 25 minus 4 AC, which is minus 4 is multiplied by 6, which is 25 minus 24, which is 1. So y equals minus b, which is 5, plus square delta of this 1 is divided by 2. The second solution, I will have 5 minus 1 is divided by 2. So this implies I will have two solutions. I will have y equals 5 plus 1, 6 is divided by 2 is 3. Other solution, I will have y equals 5 minus 1, which is 4 divided by 2 is 2. Okay, so I will have two solutions here. First solution, I will have x equals 1 equivalent y equals 3, and the second solution, I will have x equals 1 is the same, is equivalent y equals 2. Okay, but don't forget we have a symmetry, so I will have another two solutions. I will have x equals 3. I'm taking this one instead this one, and y equals 1. Okay, the second solution, I will have x equals 2 and y equals 1. So for this case, I found these four solutions. Calculate a equal to 2 is giving you only one solution, which is this one. Okay, one of these. So we don't need to calculate for a equal to 2. We don't need to calculate a equal to 2. So this one will be eliminated. We don't need to calculate another solution which is the same. So for 3, a3 is not verifying this one. If you try this one, is not verifying this, is not perfect square here, so is not valid. For number 4, the same thing, is not valid, is not perfect square, and 5 is the same, is not perfect square. 6 is not perfect square. I'm going to try 7. When we have a equals 7, a equals 7, I'm going to do the same thing. I'm going to calculate first delta. I will have 21 7 quinary square plus 60 is giving us 1089, which is 23 square. Okay, so by taking the square root of this one is giving us 23. So now let's move on to the solution. I'm going to look for x. I'm going to look for x. X is giving us minus b, minus 21, plus square of delta, which is 33, is divided by 2a, which is 6, is divided by 6. The second solution, I will have minus 21 minus 33 is divided by 6. So this one will be eliminated because it's a negative solution. This one, 33 minus is giving us 12 over 6 is giving us 2. Okay, so only one solution. I'm going to look for y by replacing number 2 into the original equation to see what's giving us. So we'll have number 4 plus y squared minus 10y plus number 5 equals 0. Okay, so we'll have y squared minus 10y plus 9 equals 0. By calculating the discriminant of this one, delta, the 10 square is giving us 100, minus 4 is multiplied by 1, 9 is giving us 100 minus 36, which is 64. 64 is the same as 8 square. Okay, now I'm going to look for y as a solution. Minus b, which is 10, plus square root of delta, which is 8, is divided by 2. The second solution, I will have y equals 10 minus 8 is divided by 2. So the first one, 10 plus 8 is 18, is divided by 2 is 9. So the second one, 10 minus 8 is 2, is divided by 2 is given as 1. I will have two additional solutions for this one. So we'll have I will have the solution of the x equals 2 equivalent y equals 9. Then I will have x equals 2 equivalent y equals 1. Okay, x equals 2 and y equals 2, we already have the same solution, so we don't need extra solution. Y equals 2. So I'm going to tick off this one. Then I'm going to look for the symmetry of this one. So the symmetry of this one is the same. Instead to tick x equals 2, I'm going to tick x equals 9. So x equals 9 equivalent y equals 2. Okay, so we did this case and this case. So let's move on to the next case. So this one, 8 is not a perfect square, 9 is not a perfect square, 10 is not a perfect square. I'm going to check 11. Okay, if a equals 11, now I'm going to replace it. I'm going to plug this one into the original delta. I will have delta, which is 21 is multiplied by 11 quinary square plus 60 is giving us 2601, which is 51 square. Okay, so now I'm going to calculate x as a solution for this one. So x, by replacing minus 3a, which is minus 3, is multiplied by 11, which is minus 3 minus 23. Okay, plus square root of delta, which is plus 51, is divided by 6. The second solution, I will have minus 23 minus 51 is divided by 6. So this solution, it will be eliminated because we have because it's negative. I will calculate this one. This one, 51 minus 23, 18, divided by 6, which is 3. I'm going to look for y by replacing this 3 into the original equation to see what's given us. So it's giving us 9, which is 3 square, plus y square, minus 5 is multiplied by 3 is giving us minus 15, y, plus number 5 equals 0. Okay, I'm going to simplify this calculation. I will have y square minus 15y, 9 plus 5 is giving us 14 equals 0. So I'm going to calculate the delta of this one. 15 square minus 4 times is multiplied by 1 and 14. 15 square is 225. Minus 4 is multiplied by 14, which is minus 56. 225 minus 56 is giving us 169, which is the same as 13 square. Okay, I'm going to determine the solutions of this equation. So I will have minus b, which is 15, plus square root of delta, which is 13, is divided by 2. The second solution, I will have 15 minus 13 is divided by 2. 15 plus 13 is giving us 28, is divided by 2 is giving us 14. The second one, 15 minus 13 is giving us 2. 2 is divided by 2 is giving us number 1. So we'll have another solution of x equals 3 as a first solution. X equals 3 and y equivalent to this solution 14. X equals 3 and y equals 1. By symmetry, instead to have x equals 3, I will have x equals 14 and y equals 3. For this solution is extra because we don't need, because we already determined this one as a first solution, x equals 3 and y equals to 1 with the symmetry. So I'm going to tick off this solution. Okay, so this is the all solutions that I found. So I have 8 solutions. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.